Hello everyone, good afternoon, right? Okay, so today we continue, okay, the last subtopic, okay, the last subtopic for chapter 4, right? There is a extraction of metals from their ores. Okay, so 4.3 extraction of metal from their ores. Right, so application of reactivity series of metal. So what is the use, right, that we learn the reactivity series of metal? So this reactivity series of metal you can use to extract, right, to extract the compound. Okay, so let's say if you want the aluminium oxide, right, so you can use the reactivity series, right, to decide, okay, how you can get the aluminium. Okay, you can extract the aluminium from the aluminium oxide. Okay, so most metal in the Earth's crust are in compounds form, okay, and in ores form which consists of other impurities. Okay, so the example, okay, so this is the example. So the metal iron, okay, the ore is hematic, all right, the composition is iron oxide. Okay, aluminium, okay, the ore is bauxite, right? And then the composition is aluminium oxide, and tin we call it as a cassiterite, so the composition is tin oxide. Zinc is ferric, okay, the composition is zinc sulfide. Okay, so you can use the reactivity series, right, to extract, okay, to extract the metal, okay, from the composition. So let's say if I want iron, right, from the iron oxide, so we can decide which metal that we can use, right, to extract, to take the iron from the iron oxide. Okay, so ores are separated from impurities by physical separation followed by extraction of metals from the ores. Okay, so the process to obtain metals from the ore. So what's the meaning of extraction of metals? So the meaning of the extraction of metal is process to obtain the metals from the ore. So let's say if I have just now example I use is is iron oxide. So how do I want to get the iron, okay, from the iron oxide? So that is called as a extraction of metals. Okay, so that process we call it as the extraction of metals. Okay, so the extraction of metals can be carried out by two methods. Okay, so the first one is by electrolysis. So this one actually you already learned. Okay, I think on form 1 or form 2, the water, yeah, form 2, I'm sorry, on chapter 5 form 2. Okay, you already learned what is actually the process of electrolysis. But in that experiment, the electrolysis, you separate the hydrogen than the oxygen gas, right? So by using the electric, okay, by using the current electric, you you connected with the wire, okay, and the battery, and then it will have the positive anode, cathode, okay, and then you have to see where the hydrogen we goes to the cathode and the anode, and the oxygen we goes to the anode, right? So that is the process of electrolysis. Okay, so we can use that process also to get the metals, okay, from the ores. Okay, so they say then that one we see which type of metal that we can use, okay, by using the electrolysis process. Okay, and then another one is by reduction. Okay, reduction of metal or using carbon. Okay, for less reactive metal, which are less reactive than carbon. So you already learned, okay, the reactivities of series of metal. So we have potassium, and then you have sodium, right? Sodium. Wait. Uh, wait. This one is actually the Greek name for the name of the metal. Okay. Okay. So I put the name here. magnesium, helium, helium, I remember like this calcium, magnesium, right? And then aluminium, carbon, okay, zinc, okay, I think ferrum, stannum, cuprum, okay, and silver, okay, silver, and the last is gold, okay. So this is the reactive series of metal. So for the carbon, you can see carbon is on this position. So we can use the reduction process, okay, for those who are below than the carbon. Okay, so this one we can use the process of reduction. Okay, and this one you have to use the process of the electrolysis. So for those who are more active than the carbon, okay, if you want to get the metals from the ores, you have to use the process of electrolysis. But for those who less reactive than the carbon, we can use the process of reduction, okay, to get the metal from the ores. Okay, so that's why we have two methods. So each method they have their own characteristics. So what method that can use the electrolysis, and what method can use the process of reduction. Okay, so you have to see the series of this reactivity series of metal. Okay, so this one is the reactive series. Okay. Okay, so means from calcium until aluminium, you have to use a process of electrolysis. Okay, this one is actually you have to flow the current, okay, through the metal. So and then it will divide. Okay, the oxygen will release, and then only it will left by the metal. Okay, and above the carbon, okay, sorry, below the carbon, the one that less reactive than carbon, let's say zinc, ferrum, stannum, plumbum, okay. So this one we use the carbon, okay, we use the carbon, okay, to extract it, okay. And for copper and mercury, we just need to extract, you just can extract it by hitting the ore in the air. Okay, while silver and argentum, you know, this one is the element, so means very stable. So we cannot extract it. So because it's only have one type of atom inside of it, right? So you don't need to extract it, okay, because it's only consists one element. Others they maybe can combine with the other element to form another compound. So that's why we need to eliminate it so we can get the metal only. But for this one, for argentum and aurum, they already exist, okay, in the element. So they will not combine with the another element to form another compound. So we can just directly take from the metal. Okay, we don't need to separate it anymore. Okay, so you have to remember which part they use the electrolysis and which part they use the reduction process. Okay, and but for copper and also for the mercury, since is a very less reactive if we compare with others, so we just need to heat it, okay, in the air, so it will be separate. Okay. Alright, so the extraction of metals from the ore. So usually we use a blast furnace. Okay, so the tin ore is mined and washed to remove impurities by flotation process. So by the flotation process, mean you already know those who that has a high density will no those who have the low density will go on the top of the part of the water, and others will submerge, right? So that is the flotation process. Okay, and the next part is tin ore is heated to remove sulfur and arsenic, okay, in it. And then the tin ore is then mixed with coke, okay, or we call it a carbon, eh? And limestone at 1300 degrees Celsius until 1400 degrees Celsius in the blast furnace. So means it need very high temperature, okay, for the metals, okay, if you want to extract the metals from their ores. Okay, and it will consist two process. The first process is the carbon remove the oxygen from the ore. Okay, and then the second one, okay, the limestone. So the limestone is to react with impurities in the tin ore, okay, to form a slab. Okay. And the molten tin and the molten slab flow to the bottom of the furnace. Okay, the slab will float, okay, will be on the top of it, and the molten tin, okay, and on the molten tin will be at the below part. Okay, so after this we will see the diagram in the video. Okay, so both are removed through an outlet pipe. So actually, at the end of product is there is a at the bottom part is the molten tin. Okay, molten tin, and the upper part is actually the slag. Okay, so this one they already have the pipe. Okay, and this one also got pipe. Okay, so that will be keep in the tank like that. Okay, and the means the slag is low density than the molten, so that's why it can float. Okay, above the molting tin. Okay, all right. So extraction method in the blast furnace. So this is the diagram. Okay, so the first part is, okay, you have to mix the iron ore. Okay, you have to mix the iron ore, okay, or iron oxide, okay, with the coke and also with the limestone. Okay, so the coke here is actually carbon. Okay, so you mix all these three, okay, and then you put inside the blast furnace here. Okay, at the top of the blast furnace here. Okay, and then after that, okay, after that a very hot blast, okay, of air is pumped into the furnace through the bottom. So here, okay, they will put hot air inside the blast furnace through this pipe. So this hot air is actually very low density, so if we go up, okay, so we go up. And then number three, the reaction in the production of iron and slag occur in the furnace at higher temperature. Okay, so the slab we burn the iron here. Sorry, the hot air here we burn the iron here, the mixture here. Okay, and then the iron and slag that is produced will melt at higher temperature in the furnace. Okay. So remember the first one, we put the mixture of the iron ore, okay, or iron oxide, okay, a coke, or we call it as a carbon, and also the limestone inside of the blast furnace. Okay, and for number two, the second step is there will be a hot air, okay, that we put, okay, at the bottom part of the blast furnace, okay, and then we go up and go burn the mixture here. Okay, and then it will melt, okay, and then it will divide by two. Okay, so the slag is the upper part here, it will go at here, and then the below part is the molten, it will go here. Okay, so actually the slag here is actually they will produce, okay, after with the calcium carbonate like that. Okay, so that one we will see the equation later, because you see the one that only we have a limestone here, right? So limestone is actually consists of calcium carbonate. Okay, but this one the mixture is only iron ore and coke. So what is the limestone doing here? So we see another other part of it. Okay. Right, the production of iron. So the first one we have to see the production of iron. Okay, remember we put two mixture there. There is a limestone and iron ore, right? So the first one we want the iron. Okay, so the first part, the production of iron. Okay, the coke or carbon will react with the oxygen, okay, in the hot air to produce the carbon dioxide and heat. Okay, so carbon inside the coke is actually a carbon, so the carbon will react with the oxygen. So where's the oxygen come from? This actually come from the hot air that you put inside the blast furnace that flow from the bottom part of the blast furnace, right? So inside of it they got the hot air, so it will burn with the carbon there, okay, and it will produce the carbon dioxide. Okay, that carbon dioxide, okay, carbon dioxide that is produced, okay, will react with the rest of the hot coke, okay, to form the carbon monoxide, which is strong reducing agent. So reducing agent means it can take away the oxygen from the iron oxide. Okay, so the carbon dioxide will react with the carbon. So where's the carbon come? It's actually for the rest of the coke that is still not burning. So it will react with the carbon dioxide. So this carbon dioxide and carbon react will produce the carbon monoxide. So this carbon monoxide is actually the one that will take the iron from the iron oxide. It will extract. Okay, it will extract the iron oxide and we will get the iron. Okay. So the carbon monoxide and carbon will reduce the iron oxide into iron. Okay. So this one I already explained just now. Okay, so this is the equation. So the iron oxide plus carbon. So carbon is will produce the iron plus carbon dioxide. Okay, and then we have another strong reducing agent that is carbon monoxide. Okay, the carbon dioxide react with the carbon, so it will produce the carbon monoxide. So this carbon monoxide will react with the iron oxide to produce the iron and carbon dioxide. So means here we have two reducing agent. There is a carbon and also the carbon monoxide. But the most strong one is actually the carbon monoxide. So this one we takes a big role, okay, an important role, okay, to reduce the iron oxide to iron. So this carbon monoxide we call it as the reducing agent. Okay, reducing agent because it can take the oxygen from the iron oxide. Okay, so let's say if it give the oxygen to iron, it means it's a strong oxidation agent. Okay, so this one because it take the oxygen from the iron, so we call it as a reducing. Okay, it's reduced, okay, from iron oxide to iron. Okay, so I explain again. Okay, so the first one, okay, we mix all the coke, okay, and calcium carbonate and also the iron ore or iron oxide, okay, inside the blast furnace. Okay, and then the second part, we give the hot air to the blast furnace, and then the oxygen, we mix the carbon from the coke to produce the carbon dioxide. Okay, and then this carbon dioxide will react with the rest of the coke that still not react with the oxygen just now. Okay, we produce the carbon monoxide. So this carbon monoxide is actually the strong strong reducing agent that will reduce the iron oxide to iron. Okay, and at the same time we also still use the carbon, okay, to take the iron oxide, okay, and so produce the iron. So means this is a question that you need to remember. So any question you want to ask teacher before I continue? For the production of slug. Any question you want to ask? No. Okay, never mind. Let's see if you really understand. Okay, I prepared a quiz for you. We will answer together. I will call any of you to answer it. Okay. Okay, so just now is the production of iron, right? Okay, so what is the purpose we put the calcium carbonate inside of it? Okay, so the calcium carbonate is actually used to produce a slug. Okay, so the limestone, okay, the limestone or calcium carbonate decompose, okay, to form a calcium oxide and carbon dioxide. Okay, so limestone is actually calcium carbonate, okay, and it will decompose to form the calcium oxide and the carbon dioxide. So the calcium oxide will react with the impurities, okay, so the impurities such as sand or silicon oxide in iron ore. So inside of the iron ore, other than iron, they still got others impurities, so such as sand. So sand is actually silicon dioxide. Okay, so it will produce the calcium oxide will react with the impurities, okay, such as sand or silicon or dioxide that is in iron ore, okay, to form a slug. Okay, so this is the equation. Calcium oxide plus silicon dioxide, and they will produce calcium silicate. Okay, so where's the silicon dioxide come from? It's actually come from the iron ore. So that means inside the iron ore is not only consists of iron. okay, or oxygen. Okay, they still got some impurities, okay, that you still need to get rid of it before you take only iron. Okay, so that's the function of the calcium carbonate. So if we take the impurities from the iron ore, okay, and then you produce the calcium silicate that produce the slug. Okay, so this is the video. So this one is Kelvin, but we use degree Celsius, so that's why it's a different. Ferrum oxide is actually the iron oxide. This one you don't need to remember the equation. Okay, the only thing you need to remember the one that I gave you just now. This one is lab. Okay, so that's the video. Okay, so we finished for the last subtopic for chapter 4. So I prepare a quiz for you. Okay, but this one we have to answer together. So I will just show you the question on the screen. So I will call any of you, okay, to answer. Okay, give me the answer. Okay. One. Okay, so we start here first. Okay, for this one I think no need because you didn't learn this one, right? So we just skip this one. You need to balance the equation, right? Mm, okay, I just answer anything because this one we didn't learn. Okay, this one is actually the higher level one. Okay, okay. So this one, which gas reduce iron ore? Okay, so I just call any name from here, and at the same time I can check the attendance too. Hua Wei Chun, are you here? Okay, you are here. So can you give me the answer for this one? Okay, so which gas reduce the iron ore? So this one is carbon dioxide, this one is oxygen, this one is carbon, this is a carbon monoxide. Okay, so you can give me, let's say this is A, B, or just put the equation here, only a simple one, right? So what's the answer? B, this one, oxygen. Which gas reduce iron ore? Oxygen reduce iron ore, okay? So let's see before this we learn, right? Is come up, iron ore is actually the ferrum oxide, okay? Iron oxide, okay? Iron ore is iron oxide. So you need to get rid the oxygen, okay? So when you need to get rid the oxygen, which gas is actually that you need to take the oxygen from the iron oxide? What gas? Are you sure the answer is B? Which gas reduce the iron ore? You see the equation, right? Iron oxide plus what will become iron? Anyone want to try? C. C is the carbon. Okay, let's see is it correct or not. It's wrong. It's supposed to be carbon monoxide. CO is a carbon monoxide. Remember I told you just now, carbon monoxide is a strong reduction agent. Okay, so means it can take the oxygen from the iron. Okay, so the answer should be carbon monoxide. Okay, what is the purpose of adding limestone? Okay, so let's see. Ang Yin En. Ang Yin En. Are you here? Okay. So what's the answer? What's the answer for this question? What is the purpose of you adding the limestone? Remember the limestone, the calcium carbonate? The first one is we want the iron. The second one is the produce of slug, right? So the calcium carbonate is actually is used to produce a slug. So I told you before this, inside the iron ore is actually does not only consist iron and oxygen. It also consists other element also. So that's why we need to add the limestone. So what is the function of the limestone here? You can say A, B, C, D. A, B, C, D. D, to remove the impurities. Okay, very good. Okay, so inside of the iron oxide, actually they consist other element other than iron than oxygen. So we already got the iron. So how about the rest of the thing that we don't need? Okay, inside the iron, so we put the calcium carbonate so it can react with the rest of the thing that we don't need, and it will produce the slab from it. Okay, so this one also we just skip this one. I just mark anyone. This one is not in your level. Okay, this one is form 4. If you learn chemistry, you learn this one. Okay, for number 5, what is the purpose of adding coke? Okay. Okay, Angelina, are you here? I don't think so. Okay, so Angelina lies wiki. Okay, so didn't come. Okay, the next part. Before I forgot, you have to remember your attendance in Google Meet. Okay, is also with tick. Okay, as the part of your, let's say for the next year, what class you will take. So this one also will be considered. Okay, the participation of the Google Meet. Okay, so make sure if you want to go like SMKE, the better class means you have to make sure you attend. Okay, all the class. Okay, and the next one. Okay, this one Ang Yi-en already done, right? Okay, I remove. Okay, so the next one is Tan Pei Jin. Are you here, Tan Pei Jin? Yes. So what's the answer for this question? What is the function or purpose you adding a coke inside of the mixture? Coke is actually a carbon. So what's the function of carbon here? You can put just A, B, C, D. A, to react with coke to produce a carbon monoxide. It's wrong. The coke is actually is a carbon. Carbon is actually is the part of the reducing agent. If you want to form the carbon monoxide, you need to have the carbon first. Okay. So the next one is Chen Juyen. Junyan, are you here? Chen Juyen. Okay, you are here. So what's the answer for this question? It says what's the name of the waste product formed in the blast furnace? There are two, right? The first one is what? The second one is what? Remember the upper part is the one that has a low density and the one is the high density. So it will be on the top or on the bottom of it. B, slug. Yes, very good. Okay, slug and iron or the molten. Okay. Okay, next one. What is the purpose of adding hot air? Oops. Chan Su In. Chan Su In. Yes, you are here. So, what's the answer for this question? What is the purpose of adding hot air? What's the answer? What's the purpose of adding hot air? So the hot air will burn the what? A, as a source of iron. Source of iron is actually iron oxide, right? Or coke. Okay. So actually the hot air is to use. So this is your answer. So let's see what is the correct one. Actually, the hot air is to react the coke with the carbon monoxide. Okay, if you put the temperature is low, okay, the coke will not react with the carbon. Okay, if you want to react the coke with the carbon, you need the high temperature. Okay, just now we already like 1,300, 1,200 something, right? So this one also I just skip this one because we didn't learn this one. This is chemistry. Okay. Okay, and number 9, what's the purpose of adding iron ore? Okay, so adding iron ore, Chong Yu Chi. Okay, so what's the answer, Chong Yu Chi? What is the purpose you adding the iron ore? Iron ore is the iron oxide. What's the purpose you add the iron oxide inside the mixture? A. Okay, as a source of iron, correct. Okay, so you want to have the iron, you have to add the iron oxide. Okay, so the next one, the last one, Mark Chit Tong. Okay, it's not here. Alright, so we try another one. Lam Yan Hei. Are you here? No, also. Lam Yan Hei, okay. Next one. Wang Ying Si. Wang Ying Si, are you here? Alright. So what's the answer for the last one? Which are the correct 4 raw materials used in the blast furnace? Yes, all except B. Coke, iron ore, hot air, limestone. Yes, very good. Okay. Right. So the next quiz I will assign in the Google Classroom. Okay, you can try to answer here. Answer at the Google Classroom. Okay. So I will stop the class here. Okay, and we continue on the next class on uh, I think on Wednesday, right? Okay, so Wednesday we enter the new chapter thermochemistry. Okay, so thank you, class. Okay, have a nice afternoon. Okay, bye bye. Jaja, make sure you give me the attendance. Bye. Thank you. Welcome.